Okay, so we'll be solving the question 8. So question 8a. In the diagram above, MN is parallel to ST. Angle MNR is equal to 230 degrees. And angle STR is equal to 76 degrees. Find the value of angle NRS. So moving on to the solution for question 8a. So we have this diagram. And we have M, T, then we have 230 degrees here. Okay. So this is an irregular shape. So we regularize the shape to be able to solve. So first, we can draw a line parallel to line SRS. To get a trapezium, or even make it more regular by extending the line M to meet line RS. Then we have a triangle and a square. So we know that the whole of this angle is 230 degrees, but then the total angle on a straight line is 180 degrees. So let's name here phi. And here u. So then we can say that the angle on line MU is 180. The whole of this is 180. Which means that 180 plus phi should give us 230. Because the whole of this is 230. So 180 plus phi should be equal to 230. So phi should be 230 minus 180. So 230 minus 180 should give us 50. So phi should be 50. So we have 50 degrees here. So we also know that the angle extended by two parallel lines are equal. So in this case, we can say that angle TSR should be equal to angle MUR. Since line MR and TS are parallel. So in that case, angle MUR should also be 76 degrees. So which brings us to this triangle. This side, which was phi, becomes our 50. This side becomes our 76. And this is the angle we are asked to find. So theta. Now we know that the sum of all interior angles of a triangle is equal to 180. So sum of all interior angles of a triangle is 180. So in that case, we can say that 50 plus 76 plus our theta, which is the angle we are asked to find, should be equal to 180. So 50 plus 76 should give us 126 plus theta should be equal to 180. So when we make theta the subject, we have theta should be equal to 180 minus 126. And when you subtract 126 from 180, we have 54. So our theta is 54 degrees. So then from the question, angle NRS, which is our theta, is 54 degrees. So therefore, angle NRS is 54 degrees. Okay, so moving on to the question B. So I read, BI, copy and complete the tables for the addition and multiplication in modulo 5. So let's copy the table. BI. This is our table for addition. But remember, this addition is in modulo 5. So modulo just means remainder. So what we do is we add the values and divide it by 5. If there is no remainder, we put 0 in the box. But if there is a remainder, we write the remainder there. Should this be addition in modulo 3, it means we add the numbers and we divide by 3. If there's no remainder, we put 0 in the boxes. And should there be a remainder, we put the remainder there. Okay, so 1 plus 2 is 3. So since 3 is less than 5, which is the modulo we are working with, we don't have to divide by 5. Now let's move on to 2. 2 plus 2 is 4. 4 is less than 5, so we don't have to divide by 5. So we write 4 here. 2 plus 3 is 5. So 5 divided by 5 is 0, since there's no remainder. 5 goes into 5 one times, and there's no remainder. So we write 0 here. 2 plus 4 is 6, and 6 is greater than 5. 5 goes into 6 one time, and there's a remainder of 1. So you write the remainder here, 1. 3 plus 2 is 5. Now when you divide 5 by 5, you get 1 remainder 0. So you write the remainder 0. 3 plus 3 is 6. When you divide 6 by 5, we have a remainder of 1. So we write the remainder here. 4 plus 2 is also 6. 6 divided by 5 is 1 remainder 1. So we write the remainder 1. 4 plus 3 is 7. 7 divided by 5, we have 1 remainder 2. And we are only interested in the remainders. So we write the remainder in this box, 2. 4 plus 4 is 8. 8 divided by 5 is 1 remainder 3. So we write the remainder here. So we'll do the same for the multiplication in modulo 5. So multiplication in mod 5. So 2 times 2 is 4. It's less than 5, so we write 4. 2 times 3 is 6. Now 6 modulo 5, which means 6 divided by 5 should give what remainder? So 6 divided by 5 is 1 remainder 1. So you write the remainder. 2 times 4 is 8. Now 8 modulo 5 is 8 divided by 5, which is 1 remainder 3. So we write the remainder, which is 3. 3 times 1 is 3. It's less than 5, so we write 3. 3 times 2 is 6. 6 modulo 5 should be 6 divided by 5, which will give 1 remainder 1. And modulo is remainder, So we are only interested in the remainder. So we write 1. 3 times 3 is 9. 9 modulo 5 should give 4. Because 9 divided by 5 is 1 remainder 4. So we write 4 here. 4 times 1 is 4. And 4 is less than 5, so we write 4. 4 times 2 is 8. And we know 8 modulo 5 is 3. 4 times 3 is 12. 12 modulo 5 should give us 2. Because 12 divided by 5 is 2 remainder 2. So we write the 2 here. So that will be the multiplication table for multiplication in mode 5. Okay, so moving on to the next question. It says, using the tables to find alpha, 4 times 3 plus 3 times 4. So we have alpha. So we have 4 times 2 plus 3 times 4. So from the table, we know 4 times 2. 4 times 2 is 3. So this gives 3 plus 3 times 4. So 3 plus 3 from the table, we inspect. So 3 plus 3. 3 plus 3 is 1. So now we have 3 plus 3, 1 times 4. So we go back again to check 1 times 4. So 1 times 4 is 4. So this gives us 4. So moving on to the B. M is such that m times n is equal to m plus m. So m is such that m times n should be equal to m plus m. So what we are saying is we are finding m, and m is a number that when we multiply with a certain number, it will be equal to that number plus itself. So we inspect the table. So now we have 4 numbers, 1, 2, 3, and 4. So let's move to the table. If m is 1, if m is 1, what we are saying is that 1 times a certain number should be equal to 1 plus 1. So we will check to see if this is true. So we check this. To see if true. If it's true, then our m becomes 1. If it's not, we move on to the next number, which is 2. And we check to see if it's true. If it's true, then our m becomes 2. If it's not, we move on to the next number, which is 3. So we do that for all the numbers to see which number satisfies this expression. So if m is 1, 1 plus 1 is 2. And 1 times 1 is 1. So obviously, it's not 1. So we move on to 2. 2 times 1 is 2. And 2 plus 1 is 3. 2 times 2 is 4. And 2 plus 2 is also 4. This should be m. M times m is equal to m plus m. So m is such that m times m should be equal to m plus m. So if m is equal to 1, let's check. 1 times 1 is 1. But 1 plus 1 is 2. So we know that this expression has not been met. So m cannot be 1. So we move on to the next value. So if m is equal to 2, then we are saying that 2 times 2 should be equal to 2 plus 2. So let's inspect. So 2 times 2 is 4. And 2 plus 2 is also 4. So we can say that m is equal to 2 has satisfied this expression. So we say that m is equal to 2 satisfies the expression m times m is equal to m plus m. So moving on to the next question. C. N such that 3 plus n is equal to 2 times n. N such that 3 plus n is equal to 2 times n. So we'll do the same thing for this question as well. So if n is equal to 1, then we are saying that 3 plus 1 should be equal to 2 times 1. So let's check our table. So 3 plus 1 is 4. And 2 times 1. 2 times 1 is 2. So it means 1 does not satisfy the expression. So we move on to the next value. If n is equal to 2, we are saying that 3 plus 2 should be equal to 2 times 2. So 3 plus 2 from the table is 0. So this is 0. And 2 times 2 from our table is 4. So we can see that our n cannot be 2 since it doesn't satisfy the expression. So we move on to the next value. If n is equal to 3, then we are saying that 3 plus 3 should be equal to 2 times 3. So let's see 3 plus 3. 3 plus 3 is 1. And 2 times 3 is also 1. So we can see that 3 satisfies the expression. And so our n is equal to 3.